Hi students, and we're going to continue with more practice for factoring polynomials. So if you feel that this is something that you've already got a handle on, try pausing the video here and doing it on your own. Otherwise, you can follow along with me and we'll factor this. So our first step is we always want to take a look at our coefficients. We've got negative 12, negative 20, negative 16. So because they're all negatives, I can choose to factor out the negative or I can choose to leave it in. It's your choice. So just to make it a little bit nicer, generally more positive functions are easier to deal with. So I'm going to factor out a negative, and I'm going to factor out what's the biggest thing that divides 12, 20, and 16? Well, that's 4. So factoring out a negative 4, here's what I'm going to be left with. Negative 12 divided by negative 4 is positive 3, so I get 3x cubed y. Negative 20 divided by negative 4 is positive 5, so I get 5. Xy squared, and negative 16 divided by negative 4 is positive 4x squared y squared. So now let's take a look at our x's. What can I pull out as far as x's? Well, I have x to the 3, this is x to the 1, and I have x squared. Well, the thing that they all have in common is an x to the 1. So I can factor out just a single x between all of them. Remember that you're factoring out what they all have in common, not what the highest one is. So here I'm going to be left with 3x squared y plus 5y squared plus 4xy squared. So finally, what's the last thing I can factor out? Well, this one has a y, this one has a y squared, and this one also has a y squared. So what's the biggest thing that they all have in common? Well, it's just a y. So we're going to have negative 4xy, and I'm going to have 3x plus 5y plus 4xy. So the neat thing is that you can go right from this first step right to this last step if you realize all at once what has to be figured out. Factored out. So let's try that with our next example. So what we want to try here is figuring out what we can factor out to do it all in one step. Now this isn't necessary, but it's helpful for later on when we have this factoring process being one small part of a greater question. So let's try building our factoring. First of all, we're going to take a look at our coefficients. So it's your choice whether you want to factor out a negative. It's always your choice. In this case, I'm just going to leave the negatives in there. They aren't causing any problems. And we're going to just focus on the numbers here. So I've got 18, 24, and 30. Well, the largest number that divides 18, 24, and 30 is 6. So now let's take a look specifically at our x. So what we have is x to the power of 4, x to the power of 5, x to the power of 3. So what do they all have in common? Well, they all have in common an x to the power of 3. So lastly, we're going to take a look at our y's. I got y cubed, y to the 4, y to the 5. What do they all have in common? Well, they all have in common a y cubed. So let's try this factoring process as a one-step process. So I want you to pause the video here and give it a shot. So what we're going to have is negative 6x cubed y cubed onto negative 3x plus 4x squared y minus 5y squared. Now notice, remember, it's your choice if you want to factor out a negative. So if I choose to factor out my negative, let's see what happens. So I could make this out front a negative 6x cubed y cubed. And factoring out a negative just changes the sign of everything inside. So this will be 3x minus 4x squared y plus 5y squared. And that's it. That's how we factor polynomials of this type.